Okay, Year 10, we're going to look at the last bit of the equations topic, and we're going to look at something called inequalities. Now with inequalities, you've seen some of these symbols before, greater than and less than, and with these questions we actually solve them with the same method as equations. So let's have a look. So just copy down that heading, and we're going to look at these symbols first. So this is the greater than symbol. You've seen that before. Now this symbol here with the extra line is greater than or equal to. So that extra line means equal to. So greater than or equal to. This is the less than symbol, and this, the extra line, is the less than or equal to symbol. So you'll see these in the upcoming questions. Now, when we solve this sort of equation, we've got a few examples to do. There's something we've got to remember, and that is we solve inequalities the same way as equations, except we reverse the inequality symbols when multiplying or dividing by a negative number. Now, that will come into play in the later questions. We're not going to use the second part of that in the first few questions, but certainly this part we'll be using. We solve inequalities the same way as equations. Okay, so this part here will be for the first few questions, and the second part will be for the later questions. Okay, so I'm going to explain why we reverse the inequality symbol in the later questions, but in the early questions we're just going to use the typical equations method. So let's just have a look at, so copy down this bit here. So that's what I like you to do. Copy down that, you've got to copy down this, and also copy down the very first question. Okay, we're going to solve that, so I'll just give you a minute to do that. Pause the video if you like. Okay. Alright, so let's start with the first one. Now, we've got to solve 2x minus 10 less than or equal to 16. So, just like a normal equation, we're going to add 10 to both sides. That gives you 2x is less than or equal to 26. And then to get the x by itself, you divide both sides by 2. Divided by 2, that cancels, and your answer is x less or equal to 26 divided by 2 is 13. That's your answer. Now so I've done the first part of the question, solve. Now it does say graph the solution on a number line. So I'm going to do a number line here. There we go. And I've got to show all the numbers which are less than 13 or equal to 13. So this, I'll put this in words. X is less than or equal to 13. Okay? Now, if I put 0 here, and the only other number I've really got to put is 13, I'll put 13 there. Now it says x is less than or equal to 13. Now, if x is equal to 13, I can show that by putting a dot at 13 and colouring that in. Now, what about x being less than 13? So, I've got to show all the numbers which are less than 13 now. Now, all the numbers less than 13 are all of these numbers to the left, so all the numbers which go this way. Okay? So, all the numbers less than 13 are to the left of 13. So there's my graph. X equals 13 here at the dot, and all the numbers less than 13 are to the left. Okay? So copy that down, including this diagram here, and we'll look at the second question now. Second question is this one. 2y minus 1 greater than or equal to 12. Okay. Now you can pause the video at any time and have a go at these questions and then check your answers. But again, we solve this the same way as an equation, so I'm going to expand the brackets. 2y minus 2 is bigger than or equal to 12. Then add 2 to both sides. That gives me 2y bigger than or equal to 14. And then divide by 2, divide by 2. That cancels. And I'm left with y greater than or equal to 7. Okay, so let's write that in words. Y greater than or equal to 7. Right, now I've got to graph that on a number line. Now with your number line, yeah, you could put all the numbers on there if you want. 1, 2, 3, 4, 5, 6, 7. You go up to 10 if you want to. Alright? And but really the only number you have to put on there is 7. That's the minimum number. Now it says y is greater than or equal to 7. Well, equal to 7 is just here, so I'm just going to colour in that dot there. There's 7. And greater than 7. So all the numbers, so if y is greater than 7, then that means all of these numbers are possible. Okay, so the y numbers greater than 7 are after 7. The y numbers equal to 7 are just there. Okay, now for your graph, this is how I would do it. I just put the number 7 there. You only need one number. I put a little dot to say y is equal to 7, and then I'll put an arrow here after saying here are all the numbers greater than 7. So you can put more numbers if you want, but the minimum amount of numbers is the 7. So I just put the 7 there. You could even put the 0 there if you wanted to, if that helps, but 7 is all you've got to put down there. Okay? So copy that down, and then we'll look at question 3. Okay, so question 3 starts off with w plus 3 over 2 is bigger than negative 1. Okay, now I'm just going to write the question down again, and then I'm going to get rid of the divide by 2 by multiplying by 2. Okay, that cancels, and then I'm going to have w plus 3 bigger than minus 2. Okay, minus 1 times 2, minus 3, minus 3. That gives me w is bigger than minus 5. Okay, so that's my answer. Now I'm going to do my number line again. I'll put 0, 1, 2, 3, 4, 5. So minus 5 is down here. Minus 4, minus 3, minus 2, minus 1. 1, 2, 3, etc. Now this says in words, w greater than minus 5. Okay? W greater than minus 5. Now, what numbers could that be? Well, it could be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. All of these numbers to the right of minus 5 are bigger than minus 5. So, now, it's not equal to minus 5, so I'm actually just going to put an open circle there to say that minus 5 is not included, but everything after minus 5 is included. Okay? So all the numbers to the right of minus 5 are bigger than minus 5. So this says, show me all the numbers bigger than minus 5 on the number line. So put an open circle at minus 5 because minus 5 is not included. W is not equal to minus 5, so you must show there's an open circle there. And everything after minus 5 is included. So even all the numbers in between minus 5 and minus 4 are also included. But minus 5 is not included, so put an open circle. Okay? So now for your answer, this is what I would do. I would just put a minus 5 on the number line. I put an open circle at minus 5 and an arrow that way. That's the minimum answer you have to put for this one. And let's do one more. Okay. Let's do something which looks quite easy. Number 4. Okay, so how about 5 bigger than x plus 2? Okay. Now, if I subtract 2 from both sides, I'm going to have 3 here greater than x. Now, 3 is bigger than x. 3 is bigger than x. And when you get your solution, it's good to have the x on the left-hand side. Now, if 3 is bigger than x, that means x has to be less than 3, doesn't it? If 3 is bigger than x, then x has to be less than 3. Alright? So, on the number line, here's 3, right? Here's 2, here's 1, here's 0, and so on. Just have to put 3 though as a minimum. Now it says x is less than 3, okay? Now all the numbers less than 3 are this way. All these numbers here are less than 3. So I put an arrow there for less than 3. I put an open circle here because x is not equal to 3. Okay, x is less than 3. So 3 is actually not included, so I've got to put an open circle there. Alright? And check back with this. What we had was 3 is bigger than x, didn't we? So if x is all these numbers here, 3 is bigger than that, isn't it? 3 is bigger than all these numbers over here. Okay? So if you get a question like that with the pronumeral on the right-hand side, just put it on the left-hand side, but you've got to reverse the inequality if you do that. Okay? Now, let's do question 5. We'll put over here. Question number 5. Alright, so we've got 1 minus 2x greater than or equal to minus 11. Okay, so let's subtract 1 from both sides. That gives me minus 2x is bigger than or equal to minus 12. Okay. Now, think back to the beginning of the lesson. We said that when you divide an inequality by a negative, you have to reverse the inequality sign. Or if you multiply the inequality by a negative, you have to reverse the inequality sign. Now, in this case, we've got a negative that we're going to be dividing by. So over here, our next line of working should be this. You leave this as it is, and you write this down with the inequality sign reversing. Okay? The reason you're doing that is because you're going to be dividing by a negative. Okay? Once you divide by a negative, this has to point in the opposite direction. I'm going to explain why that's necessary after we do the questions. Alright? Now, that gives me x less than or equal to 2 negatives are a positive, I get 6. So on my number line here, I'm just going to put a 6. X, all the numbers less than 6, so x is a number or a group of numbers, all the numbers less than 6 or equal to 6, okay? Equal to 6 is here, and all the numbers less than 6 are that way, aren't they? Okay, because you could have 5, 4, 3, 2, 1, 0, and so on. Okay? All the numbers less than 6, but you must colour that dot in to show that it's also equal to 6. Okay? Because this says x is less than or equal to 6. But this question is important because when you're dividing by a negative, the inequality sign you can see has been reversed. Alright? Let's do another one. Okay, so let's try this one. Number 6. Now, a plus 5 over minus 3 greater than 4. Rightio. Now, I'm going to write the question down again so I can draw on top of the diagram. Now, I've got to divide not negative 3 here, so to get rid of that, I'm going to times by negative 3, both sides. Right? Now, the trouble is when I do that, this must be reversed. Okay, so I'm just going to rub that. As soon as I put multiplying by negative, I've actually got to make sure this is reversed. Okay, so cancel, cancel. A plus 5 is less than negative 12, and then minus 5 both sides, and you get A is less than negative 17. Okay, so to graph that, you're going to put negative 17 there. Now it's a less than symbol, so that means negative 17 is not part of the solution. Now all the numbers less than negative 17 are this way. Okay, so for example, negative 18 is less than negative 17. So all the numbers less than negative 17 are everything to the left of negative 17 on the number line. Okay. All right, so we'll do one more just to finish off. Okay, so what about this one? Number 7, 4 minus r is less than 7. Okay, now, first thing I'm going to do is subtract 4 from both sides. That's going to give you minus r less than 7. Now think of this as minus 1r. You're going to divide both sides by minus 1, but to do that, you must write it out again. Minus 1r, reverse the inequality sign, because you are dividing by negative. As soon as you have a division by negative there, the inequality sign must be pointed in the opposite direction now. Cancel that, and you get r is greater than minus 7. On the number line, put minus 7. Greater than symbol means open circle. And all the numbers bigger than minus 7 are to the right of minus 7. So that's your solution. Okay, make sure all that's copied down. Now I'm going to explain why you reverse the inequality symbol. Okay, so first of all, let's start off with so why do we reverse the inequality symbol? Okay, why do we? Okay, let's think about it. If I've got 3 greater than 2. Okay, now if I take 2 from both sides, what do I get? 1 is bigger than 0. Now that's true, isn't it? This is also true. So I can subtract both sides and I've still got a true statement. There's nothing wrong with this. Now, what if I do start off with 3 bigger than 2 again? This time, what if I add 2 to both sides? Okay, so then I get 5 is bigger than 4. Now this is true, and this is true. So that's still a true statement, isn't it? Now, what if I start off with 3 bigger than 2? That is true. Now what if I multiply both sides by, let's say, negative 5, some negative number? Now, I get negative 15 bigger than negative 10. That is false. Okay, think about the number line. Negative 15 is here, negative 10 is here, 0 is here somewhere. So negative 15 is actually, should be less than. The negative 15 is less than, so this is false. So when you multiply by negative, you've got to reverse the inequality to make sure that the truth of the statement remains true. Okay? Now, what about, that's multiplication. What if I start off with 3 bigger than 2? What if I divide by negative 1? Okay, so we'll start off with, this is true. Okay, then divide by -1, I get -3 bigger than -2. Now that's false, isn't it? That is false. Okay? So the true statement should be -3 is less than -2. That's true. Okay? So in order to keep the statement true, when I'm dividing by negative, I've got to reverse the inequality. Okay? So if I reverse the inequality when divided by negative, I end up with a true statement. Okay? So that's the explanation of why you've got to reverse the inequality when multiplying or dividing by negative. Because if you don't, you end up with a false statement at the end. Okay, that is it for today.